We went over perpendicular bisectors inside of a triangle, angle bisectors inside of a triangle, and now we're going to go over medians. A median is a segment with one endpoint on a vertex, and then the other endpoint is on the midpoint of the opposite side of that vertex. So here's our triangle. For our first median, the endpoint lies on the vertex. Then we find the midpoint of the opposite side. So here's the vertex, here's the opposite side. The midpoint of the opposite side becomes the second endpoint. So now we just connect the endpoints. So that is one median. Vertex, opposite side, find the midpoint. Now, connect the endpoints. And that is the third median. So a triangle will have three medians. And just like a triangle has a point of circumcenter, a point of incenter, it will have a point of concurrency for a median that's called the centroid. So this point where the three medians intersect is known as the centroid. And that is the point of concurrency for the medians. You can also think of a centroid as a point of balance. And just like there was a circumcenter theorem and an incenter theorem, there's also a centroid theorem. The centroid theorem, T33, says that the centroid of a triangle is located 2/3 of the distance from the vertex to the midpoint of the opposite side. So starting at this vertex, if we were to measure the distance between the vertex and the opposite side, the centroid would be 2/3 of the way over, and then from the centroid to the side would be the other third. So here we have a vertex. Let's go ahead and name this vertex A. And let's name the centroid P. And we'll name this midpoint of this side B. So vertex to centroid is 2/3. So AP is equal to 2/3 of the distance from A to B. And PB is equal to 1/3 of the distance from A to B. So the centroid is located 2/3 of the distance from the vertex to the midpoint of the opposite side. Let's go over one other segment within a triangle. Now we know perpendicular bisector, angle bisector, median, and we're going to go over altitude next. Altitude is a segment from a vertex of a triangle to the opposite side that is perpendicular to that side. Here we have a triangle, and we're going to create our first altitude. We're going to go from the vertex to a side, and the side we're going to create a segment that's perpendicular to it. So that is our first altitude. Again, vertex to opposite side, but it's going to be perpendicular to that opposite side. There is our second altitude and our third altitude. Vertex, perpendicular to the opposite side. Three different altitudes within our triangle. If you notice, again, we're going to have a point of concurrency. The point of concurrency for altitudes is known as the orthocenter. So the orthocenter is a point of concurrency for altitudes. For a perpendicular bisector, the point of concurrency is the circumcenter. For an angle bisector, the point of concurrency is an incenter. For a median, the point of concurrency is its centroid. And for an altitude, the point of concurrency is an orthocenter.